Hi everyone, welcome to today's lesson. As we kick off our geometry unit, it's so important to understand what geometry is. So as we head out of some of our algebra topics, we're heading into our geometry unit, and geometry is the branch of mathematics that is concerned with the properties of configurations of geometric objects. Don't get too alarmed by that definition because you guys have talked a lot about geometry already in previous classes. When we talk about geometric objects, we're referring to points, lines, angles, and shapes. All right, so we're building a lot upon what you've learned in geometry from previous classes, whether that's in 5th grade, in 6th grade, or even in other courses that you might have taken. So why do we learn geometry? There are so many uses for geometry, and on this page we've kind of listed just a few of the different ways that we learn geometry. Obviously, we learn it in school, right, and in math class, but geometry really comes into play when we talk about sports and creating arenas and playing fields. All right. It also comes into play a lot when we're talking about symmetry and visual appeal, whether that's in quilts or in designs and art. A lot of time we also talk about geometry when we're calculating area and volume and building structures in houses. All right. And I thought this was really interesting, but geometry shows up a lot when we're talking about visual appeals, even in video games. So if you want to take the time to pause and read through this page, you absolutely can. This is just a few of the ways that geometry is used in the real world. All right, so let's head into today's lesson. Today's lesson, we're really focusing on shapes. We're analyzing how to classify polygons. All right, we have a few different goals today. The first and foremost goal is to understand what a polygon is and how to classify polygon by its most specific name. All right, by the end of today's lesson, you should be able to classify by its most specific name, identify similarities and differences between polygons, and using algebra, solve for missing angle measurements. All right, so let's get into our first lesson. What is a polygon? Well, before we head into the lesson, we need to know what a polygon is. A polygon is a closed plane figure with 3 or more sides. So over here on the left, we kind of have, on the left side of this image here, we have pictures of non-polygons. Now a circle is not considered a polygon because although it's closed, it does not contain sides. And when we talk about sides, those need to be line segments, straight edges, right? We have a picture of like a moon shape, a heart. These are not polygons. Another example of a non-polygon would be something like this, right? Even though we have line segments, they're not connected. And a polygon, it needs to be a closed figure. So when we get to ones that are polygons, let's look at the images on the right. These are all examples of polygons. I put a little check mark there to indicate that they are. They're all closed figures. They contain 3 or more sides, and they're all connected, right? So in today's lesson, I'm going to erase that right now. In today's lesson, we're going to start off by talking about a 3-sided polygon, which is a triangle. And we're going to really examine the different ways that we classify triangles correctly. After we talk about triangles, we're going to talk about all the different types of quadrilaterals, which you should be a little bit familiar with from 6th grade. After we talk about how to classify quadrilaterals, we're going to head into all of these other shapes and talk about how do we classify polygons. All right, so we've got kind of 3 goals for today's lesson. All right, so let's move on. Let's first start with our 3-sided polygon, which is a triangle. All right, we know a triangle is a closed figure, right? That's the definition of a polygon, that is made up of 3 line segments joined together at their endpoints. So if I were to quickly draw a triangle right here, I would create 1 line segment, another line segment, and another line segment, all of which are connected by their endpoints. So it's a little messy, but you see the little triangle that I drew here by just connecting 3 line segments. All right. If you know anything about triangles, you should know the interior sum, the sum of the degrees inside. Now a triangle contains 3 angles. You've got angle here, an angle here, and an angle here. All right. To indicate what those angles add up to, we know the interior, or the sum of the angles, a sum of the degrees inside of a triangle is 180 degrees. All right. So we've had a little background about what a triangle is. Let's talk about how to classify it. In order to classify a triangle, we use these 2 really important rules here. We classify a triangle by its most specific name by identifying information about its side lengths and its angle measurements. So let's first talk about how to classify triangles by its angles. When we talk about classifying triangles by its angles, I take a look at the interior angles, right? This angle's inside. And right here, we've got a little symbol here. Do we know what this little symbol represents? That's right. It represents a right angle or a 90-degree angle. Automatically, since this triangle contains one 90-degree angle, we automatically call this a right triangle. All right, so when we're classifying the triangle by its angles, this is considered a right triangle. Even though it has two other angles, we don't care. That right angle automatically makes it a right triangle. When I look at this second triangle here, we've got three smaller angles, less than 90 degrees or less than a right angle. If a triangle contains all angles that are smaller than 90 degrees, what do we call that? That's correct, an acute triangle, right? Acute little angles, we call it an acute triangle. So we take a look at this last one, and if we have any angle that is larger than 90 degrees, automatically call that, good, an obtuse. All right, so there are three names for classifying triangles by its angles. We've got a right, we've got an acute, and we've got an obtuse triangle. All right, so let's move on. How do we classify triangles by its sides? Now, when we're looking at the sides of a triangle, you're going to see some notation, and you kind of see it in these three examples on the bottom here. When you see little lines like this really is an important notation in geometry. This indicates to the reader that these side lengths here, these three side lengths, are congruent. That little line on the side indicates that those side lengths are congruent. So if all three line segments or all three sides are congruent, we call this triangle equilateral. All right, and I look at the second picture here. All right, well, it indicates here that this side, this bottom one, has one tick mark. But since the other two have two tick marks, that indicates that just those two line segments are congruent. So only two out of the three sides are congruent in this triangle, and we call that isosceles. This is always a tough one for students to spell. I-S-O-S-C-E-L-E-S, an isosceles triangle. Then we get to the last one. All right, so this is indicating that since it has all three different tick marks, that indicates that all three side lengths are completely different. They're not equal in length. So for instance, if one of them's 2 inches, the other one has to be different than 2 inches, and so on, okay? Now we take a look here. What do we call a triangle that has all three different side lengths? That's correct, scalene, all right? So we've talked a lot about, on this page, some features of a triangle. We've talked about the sum of the degrees, which we know is 180 degrees. We talked about how do we classify a triangle. First, by its angles, so it can be a right triangle, an acute triangle, or an obtuse triangle. Then we talked about how we classify triangles by its sides. We can call it equilateral, isosceles, or scalene. So let's take what we've just learned and let's actually apply it now. So in this example here, we're asked to solve for the missing angle measurements by writing and solving an equation. Okay, all right, so we're heading back a little bit into our algebra skills. That's okay. And then they want us to classify the triangle by its most specific name. All right, let's get started. So the first thing we're going to do is to create an equation to solve for the missing angle measurement. So I notice here that on my picture I have angle x. We know a variable represents a number. So in this example here, we do not know the value for the measurement of angle x. In order to solve for angle x, we want to use what we know about the number of degrees inside of a triangle. And from our previous side, we know the sum of the degrees inside of a triangle is 180 degrees. So let's actually start writing that out. I'm going to create an equation that shows that all three of these angles add up to 180 degrees. So angle x plus angle 20 degrees plus the 120 degrees should equal, correct, 180 degrees. We know that three angles add up to 180 degrees. From here, it's just a matter of actually solving it out using what we know about solving equations, all right? We treat the equal sign like the center of the equations. We're bringing back all those great algebra skills, all right? If you want to put a dotted line down the middle, you can. Then I combine my like terms. So x plus 20 plus 120 is 140 equals 180. I isolate my value of x by using inverse operations. I subtract 140 on both sides. I start from the left and go to the right. I bring down my x. This cancels out. X equals 40. Now you're going to notice here on the left-hand side, we've got this really great notation here. Keeping in mind that in geometry, we have a lot of wonderful notation. This reads as the measurement of angle x is equal to, and in this case, we know x is 40. Oops. So I'm going to write 40. I label my answer with degrees. This is awesome. This is my solution. It's a lot easier than writing a full solution sentence, all right? We use the measurement of angle x is equal to 40 degrees. Okay, so we finished the first part. We solved for the missing angle by writing and solving an equation. Our next part, though, is to actually classify the triangle by its most specific name. Now remember, to classify a triangle, we start by its angle measurements. I look here, we have the 40-degree angle, the 20-degree angle, and the 120 degrees. Since I automatically have an obtuse angle, I'm going to call this an obtuse triangle. But remember, when we classify a triangle, we also need to classify it by its side lengths. So is this a scalene, an equilateral, or an isosceles? Well, that's tough, right? Because we don't really have too much information here about its side lengths. But what's really cool is that if we know that all three angles are different, it tells us a lot about its opposite sides. So, since all three angles are different, all three opposite side lengths are different. And I'm trying to use that notation to indicate that those side lengths are different. So now let's go back to side lengths. Is this a scalene, equilateral, or isosceles triangle? That's correct. It's scalene. So I'm going to call this an obtuse scalene triangle. All right, we've hit both marks, and that's the end of this example. All right, so let's see if you can do it. You're going to try out these two examples. I'm sorry that they kind of cut off on the heading here that says you try, but if you'd like to pause the video right now and try out these two examples. First, solve out for the missing values using what you know about writing and solving the equation, and then I challenge you, can you classify the triangle by its angle measurements and by its side lengths? All right, so I'm going to leave it on this page. You can pause the video right now, try it out on a piece of scrap paper on your notes page, and then when you're ready, unpause the video. All right, great. So hopefully you've solved out these two examples. All right, so let's see if you got them correct. Let's do a little TV magic here. Boom. All right, so number one, you should have gotten the solution here. Measurement of angle x is equal to 30 degrees. The measurement of angle 2x equals 60 degrees. If you did not get that, double check your equation. All right, your equation should be 2x plus x plus 90 equals 180 degrees. To classify this, we call this a right scalene triangle. All right, check your work for number two, same idea. First, check your answers, double check to make sure your equation's correct. All right, and then we call this an obtuse scalene triangle. All right, so hopefully that gave you a little insight of what we're going to be doing with triangles. What we're going to head into next is quadrilaterals. All right, we know quadrilaterals. Let me change my highlighter here. A quadrilateral is a four-sided polygon. You've talked a lot about quadrilaterals growing up, all right? You know there are different names for different quadrilaterals. We have a lot of specific names. Just like how we have specific names for triangles, we have specific names for quadrilaterals. The sum of the interior angles is 360 degrees, all right? Now, so we know a little bit about the interior angles, but let's talk about how to classify it. To classify a quadrilateral, you must look at its features and name it by its most specific name. All right, so we typically do not just look at a four-sided figure and say, oh, that's a quadrilateral. We know it's a quadrilateral, but quadrilaterals have a lot more specific names. The first one we're going to talk about is a parallelogram. A parallelogram has opposite sides that are equal and parallel. Opposite angles are also equal. Now, there is a really fancy notation for parallel. If I'm trying to indicate on the figure that an image is parallel, I'm going to actually zoom in on this just a little bit. You're going to see the notation that kind of looks like this, two arrows. This tells me that those top and bottom sides are parallel and these side ones are parallel. Sorry, that should be more of an arrow. All right. Let's move to the next one. In a rectangle, opposite sides are equal or congruent and parallel. To indicate congruent or equal, all right, I like to use that notation, that equal sign with that little squiggly on top. That tells me that opposite sides are congruent. To indicate that, though, I'm going to use that little tick mark on the picture. This tells the reader that those opposite sides are congruent. We know all angles are right, so if I wanted to add in that notation, I can by using those little right angles. All right. In a square, we know it's a quadrilateral or four-sided figure that has all congruent sides and all congruent right angles. All right. To look at a rhombus, we know rhombus has opposite sides that are parallel. All sides are equal. Opposite angles are equal. So you're going to see here that we kind of have the notation for opposite angles are equal. I'm going to add 2 marks on those just to really indicate that. All right. Let's move to a trapezoid. A trapezoid is super important here. A trapezoid is a quadrilateral that only has one pair of opposite sides that are parallel. So typically you'll see the notation there. I liked this figure too because it just shows you another way that they're going to show that opposite sides are parallel here. A kite is 2 pairs of adjacent sides are equal. So that would be these 2 sides are equal and then these 2 adjacent sides are equal. Adjacent meaning next to. And 1 pair of opposite sides are equal. One diagonal bisects the other and diagonal intersects at the right angle. All right. So this definition here for kites, a little bit confusing. Don't get too worried about that. I do want you to just be familiar that there are different names for quadrilaterals. All right, so let's apply what we've learned here. So same idea as before. The first thing we're going to do is to write an equation to solve for the missing angle measurements. We're applying a little bit of our geometry here. And then the second thing, we're going to classify this shape by its most specific name. So let's start with our equation. We've got 3 angles here. We've got this x plus 30 degree angle. We've got this x plus 30 degree angle. We've got an angle x and an angle x. All right, so to create an equation, I'm going to think to myself, how many degrees are inside of a quadrilateral? That's correct, 360 degrees. So I know the sum of all 4 of these angles should equal 360 degrees. That's my equation there. So I'm going to start off with x plus 30. That's my first angle here. I'm going to my second angle, x plus 30. So I'm adding to that this second angle, plus this third angle, plus this fourth angle, is equal to 360 degrees. All right. To solve this out now, we're going to use what we know about solving equations. All right. So I'm going to create a dotted line down the middle if I need to. I'm going to start on the left. I'm going to combine my like terms. X plus x plus x plus x gives me 4x plus 30 plus 30, combining my like terms, including the sign before it, plus 60 is equal to 360. To solve for x, I get rid of that kid first, right? I get rid of that constant. I subtract 60 on both sides. We get 4x equals 300. I divide by 4. I ran out of room, sorry. X equals, go ahead, do that math in your head a little bit. Okay, 75. So the measurement of angle x is equal to 75 degrees. I circle my answer here. If I wanted to get fancy, I could also solve for these missing measurements by plugging in x for 75 degrees. But I'm going to stop here for now because we've just solved for the missing angle measurement. All right. Now, if I look here and I say, how do I classify the shape by its most specific name? Well, let's take a look. It's a 4-sided polygon. I'm going to actually erase some of this work here on my picture. All right. And let's actually talk about this. Since it's a 4-sided polygon, we know it's a quadrilateral, but we want its most specific name. So I'm going to ask myself, what type of quadrilateral is this? That's correct. It's a trapezoid. All right. So we've hit both marks here. We solved for the missing angle measurement. Measurement of angle x equals 75 degrees. If we want to get fancy, we can write the measurement of angle x plus 30 equals, I'm going to plug that in, 105 degrees. All right, we've classified by its most specific name, which is a trapezoid. All right, hope you're staying with me. So we've talked about triangles, we've talked about trapezoids. Well, what do we call everything else? All right, everything else has its most specific name. We know a 5-sided figure is a pentagon, a 6-sided figure is a hexagon, and so on, right? When we take a look at how do we classify them, we really just use the words regular or irregular. Regular polygons are polygons that have congruent, I'm going to use that symbol, sides and congruent angles. So these are the polygons that you typically saw growing up, right? These beautiful, I want to say beautiful, right? Beautiful shapes, those ones that you usually see on like Sesame Street or something. And the reason those are nice and pretty, what we say pretty, is because every side length is congruent and every angle measurement is congruent or the same in all of these. So to classify this shape here, I would first count the number of sides, 1, 2, 3, 4, 5, 6. So we know it's a hexagon, right? And then I'm going to say, all right, well, since all the sides are congruent, all the angles, we'd call this a regular hexagon. All right? So if regular polygons have congruent sides and congruent angles, what do you think irregular ones have? Yeah, it just doesn't have congruent sides. So it doesn't have congruent angles and congruent sides. So all of these pictures over here are considered irregular polygons. It doesn't mean there's anything wrong with them. It just means that they're not congruent sides and angles. So for instance, I could draw this polygon here. And this is still considered a polygon. It's just considered an irregular polygon. So to figure out what type of irregular polygon, I do the same thing. I count the sides, 1, 2, 3, 4, 5, 6. So it's still a hexagon, but we just call this an irregular hexagon. All right, so we've just done a lot. Let's summarize everything that we've learned in today's lesson. All right, we first started by talking about polygons. We're going to consider this almost like the umbrella topic, right? Everything we talked about today falls under the identification of a polygon. The first thing we talked about were triangles. And we talked about if it's a 3-sided polygon, we call it a triangle. But we know we don't just say triangle, we identify triangles by its sides and by its angles. So that's the way we classify a triangle. Then we talked about all the different ways we classify a 4-sided polygon, and that's a quadrilateral. But similar to triangles, this is a little messy, quadrilateral. But similar to triangles, we don't just call it a quadrilateral, we have specific names for those quadrilaterals, right? So looking at its features and asking myself, is it a trapezoid, is it a parallelogram, is it a square, and so on. Any other polygon, we just classify it by its number of sides, and we just call it regular or irregular. So to classify all other polygons, okay, we look at the number of sides, and then we call it regular or irregular. All right, so that kind of summarizes everything that we've talked about today. If you need to screenshot this page so you kind of have a reference point. All right, I hope this lesson helped as we continue and we start our unit on geometry. Thanks for tuning in today. Hope this was helpful.